NCN. Apply formula. NCR formula. NCR, that is 4n factorial by 4n minus 2n factorial is 2n factorial into 2n factorial or factorial. Similarly, 2n factorial by n factorial into n factorial. So this can be written as 4n factorial into n factorial whole square denominator, okay, by 2n factorial whole cube. 2n factorial whole square into 2n factorial. Now 4n factorial can be written as 4n into 4n minus 1, 4n minus 2, 4n minus 3, so on, 4, 3, 2, 1 into n factorial whole square. We can keep n factorial whole square into 2n factorial whole square aside, and then I'll write in the value of the remaining. So there is 4n factorial and then n factorial whole square, and then 2n factorial is 2n into 2n minus 1, 2n minus 2, 2n minus 3, so on, 4, 3, 2, 1. Here, the value of this is 4n. When you take 4n, 4n minus 2, 4n, 4, 2 as one part, 4n, 4n minus 2, 4n minus 4, and then 4, 2, one part, and the remaining is 4n minus 1, 4n minus 3, and then so on, 3, 1. Remaining is, I'll write here, n factorial whole square in the beginning, and then denominator is 2n factorial whole square, 2n factorial whole square. I can write into 2n factorial whole square here, and then 2n here. This 2n factorial. 2n factorial whole square can be written as 2n, 2n minus 2, 2n minus 4, so on, 4, 2. And then into 2n minus 1, 2n minus 3, into 3, 1, then whole square. This becomes n factorial whole square by 2n factorial. And then when you take 4n, 4n minus 2, 4n minus 4, 4, 2. When you take 2 power 2n, isn't it? Here I'll take 2. 2n terms will be there. Among 4n terms, 50% is 2n terms. From each term, if you take common, it 2 common. 2 into 2n, 2 into 2n minus 1, 2 into 2n minus 2. So this becomes 2n, 2n minus 1, 2n minus 2. When you take 2 power 2n common, this becomes 2 into 2n, 2 into 2n minus 1, 2 into 2n minus 2. So this becomes 2n factorial. And the remaining is 1, 3, 5, so on, 4n minus 3, 4n minus 1. Okay, right. Similarly, denominator is, when I take 2 common here, 2 into 1, 2 into n minus 1, 2 into, this becomes 2 into 1, 2 into 2, 2 into 1, 2 into n. So this becomes 2 power n into n factorial. And the remaining is 1, 3, 5, so on, 2n minus 3, 2n minus 1, power 2. This 2 power 2n, this becomes n factorial whole square by 2n factorial. And then 2 power 2n into 2n factorial. Okay, and then 1, 3, 5, so on, 4n minus 1. Denominator is 2 power n into square is 2 power 2n. And then this becomes n factorial whole square. Remaining is 1, 3, 5, so on, 2n minus 1 whole square. So 2 power 2n gets cancelled, 2n factorial gets cancelled, n factorial whole square gets cancelled. Remaining is 135 so on 4n minus 1, 135 so on 2n minus 1 whole square. That's the answer. Important for 7 mass. Important for 7 mass. So 4n C2n. Look here. When I write in the 6, 2, 4, 6, 8. This 2 into 1, this 2 into 2, this 2 into 3, this 2 into 4. I can write it as 2 power 4. 2 power 4 into 1, 2, 3, 4 as 4 factorial. So if it is 2 into 4, this can be written as 2 power 4 into 4 factorial. If it is 10, 2 power 5 into 5 factorial. If it is 20, 10, 12, 14, 16, 18, 20. 20 can be written as 2 into 10. 2 power 10. 2 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 power 10 into 10 factorial. If it is 100, 2 power 50 into 50 factorial. If it is 4n, 2 power 2n into 2n factorial. If it is up to 2n, 2 power n into n factorial. 2n, this can be written as 2 into n. 2 power n into n factorial. So that's the process of writing this. Okay. Right. We'll move to next one. If a set A has 12 elements, find the number of subsets of A having first one 4 elements, next one at least 3 elements, at most 3 elements. Number of elements in set A is equal to 12. Number of 4 elements subsets is whenever you select 12, 4 will get into a 4 element subset. So answer is 12. Okay. Next, number of ways of selecting at least 3 elements. Next one, the required subset contain at least 3 elements is equal to how much? At least 3 means 12C3 plus 12C4, 12C5, so on up to 12C12. Isn't it? So we know that when you add 12C0 plus 12C1 plus 12C2 for this becomes 12C3, 12C4, 12C5, and then so on 12C12, and then minus 12C1, 12C0, minus 12C1, minus 12C2. We know that the value of this is 2 power NC0, NC1, NC2, NCn is 2 power n. Is 2 power 12 minus 12C0 is 1, 12C1 is 12, 12C2 is 12 into 11 by 2, that is 66. 2 power 12 is 4096 minus 79. There is a 4023 will be that. 79, 4017. When I add 79, it becomes 96. So 4017 will be the answer. Right, and we'll go from the at most 3 elements. Required subset in the containing at most 3 elements. It may have 0, 1 to 3 elements. I can write it as 12C0 at most. At most means up to 3 elements. There is 12C3. 12C0 is 1, 12C1 is 12, 12C2 is 66. 12C3 is 12 into 11 into 10 by 3 to 1. This becomes 6 ones, 6 twos, 220 plus 79. 220 plus 79. This becomes 220. 66 plus 12 is 78 plus 1 is 79. Okay. This becomes 299. So 299 subsets can be formed which contains at most 3 elements. Okay. Find the number of ways of selecting a cricket team of 11 players from 7 batsmen and 6 bowlers such that there will be at least 5 bowlers in the team. At least 5 bowlers in the team. Can do using a tabular column here. I'll draw like this. I divide into 3. Batsmen is 7. Then bowlers is 6. We have to form a committee. Number of containing 11. Number of ways of selecting 11 players. Okay. Just it may contain this. I can take at least 5 bowlers. I taking 5 bowlers here. Since I need 11 players, I select 6 batsmen or 6 bowlers maximum. Here I'll taking 5 batsmen. Since only bowlers are 6, at least 5 bowlers means possibility is 5 and 6. Number of ways of selecting 11 players is when you're taking this row 7C6 into 6C5. Next one, 5 batsmen, 6 bowlers can be done in 7C5, 6C6. So total number of ways of combinations of selecting 11 players is 7C6, 6C5 plus 7C5, 6C6. Therefore, 7C6 is 7. 7 into 6, 65 is 6. 7C6 is 7 plus 7C5 is 7C2. 7C2 is 21 and then 66 is 1. So 42 plus 21. There is 63 combinations will be there. 63 ways we can select 11 players which contains at least 5 bowlers. Which contains at least 5 bowlers. Next. If 5 vowels and 6 consonants are given, then how many 6-letter words can be formed with the 3 vowels and 3 consonants? We are given 5 vowels and 6 consonants. How many 6-letter words? 6-letter words means selecting 3 vowels and 3 consonants is different. After selecting, we have to form 6-letter words. After selection, we have to do arrangement. So, number of vowels given is 5. Number of consonants given is 6. Number of ways to form 6-letter words with the 3 vowels and 3 consonants selected from 5 vowels and 6 consonants is equal to. Out of 5 vowels, we have to select 3. It can be done in 3 ways, 5C3 ways. 6 consonants are given. 3 consonants can be selected in 6C3 ways. How many we selected? 3 vowels and 3 consonants. It can be arranged in 6 factorials. So 5C3 into 6C3 into 6 factorial words can be formed. Okay. So after selection, we have to form words within 6 letters. So it can be done in 6 factorial. Since here the 6-letter words are asked, how many ways we can select 3 vowels and 3 consonants means 5C3 into 6C3. There ends the matter. Since we need to form 6-letter words, you arrange the selected 6 letters in 6 factorial words, 6 factorial ways. Okay. There are 8 railway stations along a railway line. How many ways can a train be stopped at 3 stations such that no 2 stations are consecutive? So let number of railway stations. Number of railway stations given. Number of railway stations is equal to 8. We have to stop 3 stations and then remaining 5. So number of stopping railway stations. Three. Non-stopping railway stations. Non-stopping railway stations is equal to 5. So I consider railway stations 5 as R1, R2, R3, R4, R5. In between them, 1, 2, 3, 4, 5, 6 places will be there. In between non-stopping 5 railway stations, there are 6 stoppings, possibilities. In those 6, 3 stoppings can be selected in 63 ways. In between 5 non-stopping railway stations, there are 6 opportunities to select 3 stations. Therefore, number of ways train can stop in 3 stations, such that no 2 are consecutive. So it's nothing but 63. Number of ways of selecting 3 stations, such that no 2 of them are consecutive, is 63. 63 is nothing but 20. 63 is nothing but 20. There is 20 ways they can stop the railway station. 6, 5, 4 by 3, 2, 1. 5, 4 is 20. The next move to next problem. Next one is find the number of ways of forming a committee of 5 members out of 6 Indians and 5 Americans, such that always the Indians will be in majority. Look here, taking tabular column, first column, Indians and then Americans, number of ways of selecting. So first one, Indians total is 6, and then Americans 5. And then number of ways of selecting a committee of 5 members. So Indians, I select the 5 Indians will be in majority. So I select 6 Indians and no Americans, and 5 Indians, 1 American, and then 4 Indians, 2 Americans. When you go for 3 Indians, 3 Americans, equal in number, therefore not possible. 2 Indians, 4 Americans, Americans will be in majority. So these are the 3 ways. So is it clear? I'll do like this. So this can be done in 4 and then 2. So it can be done in 66 into 5C0, 65 into 61, 5C1, sorry, and then 64, 5C2. 66 is 1 and 5C0 is 1, that is 1. 6 into 5, 30, and then 64 is 62, 62 is 15, 15 into 10, 150. 64 is 15, and then 5C2 is 10. Okay, therefore total number of ways of forming 5-member committee is, and then 150, 180, 181 ways are there. 66 is 1, 5C0 is 1. Okay, 6 members are formed. 65, 5C1, 6 members. 65, 6, 5 is 30. And then 64, and then 5C2. This becomes 15 into 2, 10, 150. Totally 181 ways we can select into, such that the Indians will be in majority. A question paper is divided into 3 sections ABC, containing 3, 4, 5 questions. Alternate. Find the number of ways of attempting 6 questions, choosing at least 1 from each section. So the number of ways in which 12 things be divided into find the number of ways in which 12 things be divided into 4 equal groups, one distributed to 4 persons equal. Next one, the number of ways in which 12 things be divided into 4 equal groups. 4 equal groups means formula 4n things be divided. 4n things be divided into 4 equal groups is 4n factorial by 4 factorial into n factorial whole to the power of 4. So according to this, here 12 things be divided into 4 equal groups. So there is a 12 factorial. There is a 12 factorial by 4 factorial into 3 factorial whole to the power of 4. So each group contains three elements. So 4 into 4n things. N is equal to 3 here. 4n things means 4 into 3, 12 factorial by 4 factorial into 3 factorial whole to the power. If it is distributed between 4 persons, then the formula is 4n factorial by n factorial whole to the power of 4. So this can be done in 12 factorial by 3 factorial whole to the power of 4. Formula distributed between the person. There is a dividing into 4 equal groups. Next one. Okay. A class contains 4 boys and G girls. Every Sunday, 5 students with at least 3 boys go for a picnic. A different group is being sent every week during the picnic. The class teacher takes gives each girl in the group a doll. If the total number of dolls distributed is 85, then find the G. Okay. Number of boys given is 4. Number of boys given is 4. And the number of girls given is G. G girls are given, 4 boys are given. Since there should be at least 3 boys in 3 boys, it can be done in 2 ways. Look here, there's girls. G1, 1 girl is taken, 3 boys are taken. Girls and boys. Number of girls in G1, there is group 1. There is forming first group. I can consider it as a group rather. Boys and girls. In first group, there are 3 boys and 2 girls. And then second one, 4 boys, 1 girl. In total number of during the picnic, the class teacher will take each girl in the group will give each girl in a group a doll. So at least 3 boys must be taken by the class teacher to the picnic. So 3 boys, at least 3 boys means totally 4 boys are there. Possibility of at least 3 is 3 boys and 4 boys. Okay, first one 3 boys, then 2 girls can be taken since 5 students must be taken to the picnic. So with at least 3 boys means 3 boys and 2 girls. 3 boys and 2 girls. First group, 3 boys and 2 girls. In how many different ways you can give a doll to a girl? Means I can select 3 boys in 4C3 ways and 2 girls in GC2 ways. Since whenever she selects 2 girls, 2 dolls will be given. Okay, and then number of ways of selecting girls in group 1 and group 2. Writing the 2 things here. Then plus in second group, 4 boys can be selected in 4C4 ways and a girl can be selected in GC1 ways. Then the number of dolls can be given is 1. Since each group can be given 2 girls, since each group contains 2 girls, it can be distributed in 2 ways. Here, each group contains only 1 girl. It can be distributed in 1 way. So, given the value of this is 4C3 is 4, GC2 is G into G minus 1 by 2, G into G minus 1 by 2 into 2, plus 4C4 is 1, and GC1 is G, and then into 1. And then total number of distributions given this cancel G 4G square minus 4G plus G is equal to 85. So this can be written as 4G square minus 3G minus 85 is equal to 0. This can be written as 4G square minus 20G plus 17G minus 85 is equal to 0. So 4 into 85 is then 170 into 2. No? So this can be done in 17 into 10 into 2, that is 17 into 20. So minus is minus 3G, right? 4G into G minus 4 and then g minus 5, and then 17 into g minus 5 is equal to 0. So g is equal to minus 17 by 4 is not possible. Girls cannot be in ratio. Therefore, the only answer is girls must be 5 in number. G is equal to 5 is the answer.